Hey everyone, and welcome to This Explainer. Today we're doing something really cool. We are going to unpack the invisible rules that govern literally every single action you take in your daily life. Whether you're just lifting a heavy book off your desk, kicking a ball around outside, or watching a massive crane build a skyscraper, you are seeing the fundamental laws of physics in action. We're going to decode exactly how force, work, and energy all tie together to help us get things done.
Okay, before we really get into it, I want you to imagine something. Picture yourself walking up to a massive, solid brick wall. You put your hands flat against it, and you push with all your might. You push all day. Your muscles are absolutely aching, you're sweating, you are completely exhausted. So, scientifically speaking, according to the strict laws of physics, have you actually done any work? Keep that in the back of your mind because the answer might completely surprise you.
Here's our roadmap for today. We'll start with the fundamentals of force, figure out if friction is our friend or our foe, uncover the true science of work, look at energy in its many forms, and wrap up with mastering simple machines. Let's jump in.
All right, part one, the fundamentals of force.
So, what exactly is force? At its most basic level, whenever you interact with your environment by pushing or pulling something, you're applying a force. It's literally just that, a push or a pull. When you push the pedals of your bike to go forward or yank open a heavy door, you're generating force. It is the absolute vital spark that gets stationary things moving or moving things to change what they're doing.
And you know, force is definitely not a one-trick pony. It doesn't just push things forward. It can stop a moving object dead in its tracks, like a goalie catching a football. It can crank up an object's speed or slow it way down. It changes direction, like a cricket bat spin perfectly redirecting a fastball right to the boundary. And, maybe the most fascinating part, force can actually change the physical shape of an object. When you squish a balloon, or when a baker kneads bread dough, the sheer force of their hands is literally altering the shape of the material.
Now, what's really wild is that all of these forces fall into two very distinct buckets in nature. First, you've got contact forces. This means physical touch is 100% required. Think of the muscular force you use to kick a ball or heave a heavy backpack onto your shoulders. Your muscles have to physically connect with the object. But then you have non-contact forces. A magnet exerts a magnetic force that yanks iron nails toward it from a distance, like magic. Gravity is another huge one, pulling an apple out of a tree and down to the ground without any invisible string attached.
Moving right along to part two, friction. Is it our friend or our foe?
Well, this brings us to friction, which is a super specific and, let's be honest, sometimes incredibly frustrating contact force. Friction is basically the universe's built-in resistance mechanism. Whenever two surfaces touch, friction pushes back in the exact opposite direction of the motion. If you roll a ball across your living room floor, it obviously doesn't roll forever, right? It gradually slows down and stops. Why? Because the floor is constantly applying a frictional force against the ball, resisting its movement.
So, friction kind of lives a double life. It's absolutely essential on one hand. It's the only reason you don't instantly slip and fall on your face when you try to walk. It's why your pen actually leaves ink on paper. If paper were perfectly frictionless, your pen would just uselessly slide around. But on the flip side, friction is the exact reason the soles of your favorite shoes eventually wear out. It slows cars down, forcing us to burn more fuel, and it creates this unwanted heat that damages machinery, which is why we're always having to oil up car engines and sewing machines.
Which brings us to part three, the true science of work.
Okay, now that we've got a handle on pushing, pulling, and resistance, we really need to completely redefine a word you probably use every single day: work. In the world of physics, for work to actually happen, two very strict rules apply. You have to apply a force, and the object absolutely must move in the same direction as that force. If there's zero change in position, I don't care how much effort you're putting in, science says you have done exactly zero work.
And bringing it back to that brick wall question from earlier, here's the aha moment. If you're pushing a stationary wall, you might be totally wiped out by the end of the day. But because that wall hasn't moved an inch, zero work was done. Nothing. But if you just push a tiny little toy car across the floor, you've applied force, it changed position, and boom, work is officially done.
All right, part four, energy in many forms. So to actually apply a force and do this work, we need fuel, right? We can't just create movement out of thin air. That fuel is energy. Energy is simply your capacity to perform work. If work is the action, energy is the potential making that action possible. And the coolest thing about energy is that it is absolutely everywhere in nature. It's constantly transferring and transforming, even when we can't see it happening at all.
And energy takes on so many wildly different forms. You've got mechanical energy, the energy of position and motion, like a speeding car. You've got heat energy from burning fuels like coal, and light energy from a light bulb or the sun. Speaking of the sun, we grab that renewable solar energy to heat water and make electricity. We harvest wind energy with those massive turbines, and hydro energy by letting water rush out of dams to spin giant generators. Even the sound of my voice right now is a form of energy produced by vibrations.
Finally, let's jump into part 5, mastering simple machines. Okay, so we know the rules of nature now. Force, friction, work, energy. But how do humans actually use these rules to our advantage? How do we build massive skyscrapers? Well, the secret is simple machines. A simple machine is a brilliantly basic tool, usually with very few moving parts, maybe not at all, that mathematically hacks force. Now, it doesn't change the total amount of work you have to do, but it does something better. It either changes the direction of the force, or it drastically reduces the sheer muscular effort you have to put in. A classic ancient example here is the lever. Just think of a long stick resting on a pivot point used to pry up a heavy boulder. Levers are broken down into 3 specific classes based entirely on where 3 things are: the pivot point, the heavy load, and your physical effort. In a first-class lever, like a seesaw, the pivot is dead in the middle. In a second-class lever, like a wheelbarrow, the heavy load sits in the middle so you can lift insane amounts of weight. And in a third-class lever, like tweezers, your effort is in the middle to give you hyper-precise control.
Then there's the absolute genius of the pulley. It's really just a grooved wheel with a rope looped around it. But think about using a fixed pulley to draw a heavy bucket of water from a well. It doesn't make the water any lighter, but it changes the direction of your force. Instead of straining your back to pull up, you just use your own body weight to pull down on the rope. You're literally making gravity do the hard work for you. And a movable pulley takes it a step further. It moves with the load and actually cuts the physical effort you need right in half.
Or take the beautiful simplicity of an inclined plane, which is really just a ramp. If you're pushing a heavy box up a ramp, sure, you have to push it a much longer distance than if you just deadlifted it straight up into the air. But it requires a tiny fraction of the muscular force. You are basically trading distance for ease, making a completely impossible lift totally doable. So as we wrap up this explainer, I've got a quick challenge for you. Take a second and just look around the room you're in right now. That doorknob? It's a wheel and axle. The knife in your kitchen drawer is a wedge. Invisible forces of gravity and friction are keeping your furniture plated exactly where it is. Every single action you take and every tool you pick up is this incredible mathematical manipulation of force, work, and energy. The physics of getting things done is literally at your fingertips. Keep looking at the world a little closer, and I'll see you in the next one.